All right, in number 41 from section 3.2, we're looking for the difference quotient using this function. So with difference quotients, I'd like to split it up and find this first part first, and then the second part of the numerator, and then put them together before I put it over h. So I'm going to do f of x plus h first. So I'm going to restate this statement, but leave parentheses for the x's, so I can put in an x plus h. So that's x squared minus 3x plus 2, but my input is x plus h. So instead of x, I'm going to write x plus h, and that's it. All right, now I need to evaluate this. So I need to square that first term. So that's x squared plus 2xh plus h squared. And then the second term I have to distribute my negative 3. So I get negative 3x minus 3h. And then I have a plus 2. And let's see, I don't have any like terms here, so that's as simple as I can make it, and that's just what it's going to have to look like. Now for my second part of my numerator, I have a negative f of x. So that's this thing with a negative. So that's negative x squared minus 3x plus 2. Actually, I'm going to move this over here so I can line up my negatives, my negative f of x, sorry, can't talk, like terms, that's the word I'm looking for, sorry. Okay, so I'm going to distribute, and as I distribute, I'm going to put it under the corresponding like term. So negative x squared goes right here, and then I have a negative times a negative 3x gives me a positive 3x, and here's my x term, and then I have a negative 2, and there's my like term. So my like terms, I combined the variables. That should be a squared, sorry. So my x squared are lined up, and my x's are lined up, and my constant is lined up. So now when I go to put this into my fraction, I combine that those two pieces in my numerator, and these will cancel, and these will cancel, and these will cancel. So for my numerator, I get, well, I guess I'll just keep my colors here. So for f of x plus h, really all I have to write is this part, but just to, I want to add this extra step just to show what I was doing there. So I did, for f of x plus h minus f of x all over h equals, and then I have x squared plus 2xh plus h squared minus 3x minus 3h plus 2, and then I have a negative x squared, a positive 3x minus 2 all over h. But what I did above, in that line above right there, is that I realized that those x squareds are going to cancel, and the 2's are going to cancel, and the 3x's are going to cancel. So in my reduced form, and once you understand how this all comes together, you can skip this intermediate step right here and jump to this, and you get 2xh plus h squared minus 3h all over h. So since every term is over h, you can really decompose that fraction to be each piece is over h. Again, this is an intermediate step to show my thinking, but you don't have to write that intermediate step. And then once I do that, I get my h's are going to cancel here, and here, and here. Those all turn to 1's. And I'm left with 2x plus h minus 3.